Hello everyone, welcome back to another BGCSE past paper review. Today we are reviewing another combined science paper, and this is a paper 2 from the year 2021. Now again, remember always, before you start this examination, write a school number, write your candidate number, which is your personal number, your surname, and your initials. Again, before you start the examination, always read through all the instructions carefully, and if you have any queries at all, clarify those with your examiner. Again, they will provide you with a periodic table, which is a very awesome thing. So you have this as your guide. Now let's jump into the first question. And the first question reads that atoms can form charged particles called ions. So atoms can form ions and they are charged particles. It said describe what happens to metal atoms and non-metal atoms as they form ions. Include information about the charge of the ions formed. And so for metals, let's talk about what are metals, and we're going to include the charges on the ions that are formed. So first thing, how metals form ions is simple, that they lose electrons. So we're going to say they lose electrons. All right, that's how they become ions. They lose electrons and become positively charged. All right, and become positively charged. Now, a point to note as well is that when they become positively charged, they are called a specific type of ion, and that is called cation. They become positively charged. All right, and so let me just make a note right here that they formed what they call cations. They form cations. All right, and cations are positively charged ions. All right, and so for nonmetals now, nonmetals they gain electrons. And remember, the electrons are negative, right? So think about metals. If you lose negative things, you become more positive, just like us. Once we stop doing negative things, we become more positive. All right, so drop all the negativity and you become more positive, just like metals. Yeah? All right, so non-metals now, they gain electrons. So they gain electrons and become, let's put electrons up here. Electron or electrons, because it could be one or more than one. So non-metals now, they gain electrons and become negatively charged, okay? And become negatively, all right, negatively charged. And again, just to make a note, they form anions. So anions now are negatively charged ions. All right, excellent. So they form, let me put this right here, that they form negative charge ions called anions. All right, next part of this question, it states here that oppositely charged ions, let me go down a little bit more. Yes, the oppositely charged ions form ionic compounds, right? The chemical formula for the compound form when potassium bonds with oxygen. All right, so quick thing here, just to kind of show you what's going to happen here, is that potassium, look at the periodic table, you'll notice that potassium is from group 1, so potassium will form a positive 1 ion, okay? Now, oxygen is from group 6, which means it has 6 valence electrons. Therefore, it needs 2 more electrons to become fully stable. Hence, oxygen taking on 2 negative will become a 2 negative ion. And so to form the compound, we're going to crisscross this. So the positive one is just 1. So 1 will come here, and then the 2 will come down for the potassium. So what we're going to have as a formula, it is K2, because remember now, based on that crisscross thing, we need 2 potassium, so it's going to be K2. And we need 1 oxygen, so it's going to be O. We do not write the number 1 in the formula, okay? So that's K2O. All right. Now, it's explain in terms of electron transfer, what happens when potassium bonds with oxygen. So what happened here is simple this. So when potassium bonds with oxygen is that 1 electron, since there is only 1 electron in the outer shell of potassium, so we're going to say 1 electron, just single 1 electron alone, is transferred, okay, is transferred, it's transferred from each, I'm going to say each because you have 2 potassium here, right, from each potassium atom, all right, from each potassium atom, all right, to fill the outer shell, okay, to fill the outer shell, which is the valence shell outer shell of oxygen. All right? Right. All right. So you can go back to the bonding lesson and you will see exactly how this actually works, how metals lose electrons and non-metals gain in forming ionic compounds. All right. So we are good at that. The outer shell, I should say, is actually called a valence shell, right? So let me just put valence shell in bracket here. So you know that the outer shell is the same thing as the valence shell. All right. So let's go to part C. It's a one property of compound formed when potassium bonds with oxygen is a high melting point and high boiling point. So in other words, ionic compounds, they have high melting and boiling point, right? Now, to explain in terms of bonding why potassium compound formed as a high melting and boiling point. Again, because of ionic compound, but you can't use that as your answer. So what you're going to say is that the bond is strong. So the bond that is formed, between them is strong. Okay, so there's a strong bond between them. That's the first thing I talk about. That is strong bond that is formed. And not only that, why it's also strong, and it's simply because you have a positive and negative bond. Let's put that there. So the bond that is formed between them is strong. And they're going to say now when negative ions bond with positive ions, positive ions, the intermolecular force is very strong. The intermolecular force is very strong. And so when it's strong, then it's going to be hard to change the state of the substance. All right. So strong bonds, it take a lot of heat energy to change the state of the substance. All right. So can you even mention that as well? All right. So for part 2, it's to give another property of potassium compound form. So besides that, having high melting and boiling point, what are some of the properties we can talk about? Ionic compounds. So think about ionic compounds. And there are a number of properties here. One is that they're going to be polar. And polar mean that they have slightly positive and slightly negative ends, and which means also they can dissolve in water. So I'm going to put that as the next one too, again, soluble in water. So ionic compounds are generally soluble in water, okay? Because of, again, because they are polar substance can dissolve in water. Not only that, they can conduct electricity. Let's put that again, conduct electricity. And I'm going to make a note right here that when they can conduct electricity, when molten or in solution. So let's put in bracket here, when molten. So in bracket, we're going to put when molten, because only the molten stage or in solution, right? So that's what you need to know as well, because ionic compound by themselves, some of them tend to be salts and they cannot conduct electricity unless they're in a solution state or if they are molten. All right, so let me just kind of put this at the bottom right there, so a little bit better. So or molten, all right, or in solution. All right, so yeah, that's answered that part of the question right there. All right, so soluble in water, polar, definitely conduct electricity in molten state or if in a solution. Now for part 2, well, question number 2. It's a survey to show the effectiveness of the various birth control method was conducted in New Providence. It said the effectiveness of each contraceptive method was assessed for 100 women. The results are presented in the table below. All right, so these are the information here. We have the method of contraception, and then we have the pregnancy per 100 women. And so we have the rhythm method, we have the condom, we have the diaphragm, and with spermicide, withdrawal of penis before ejaculation, spermicidal cream only, IUD, which is intrauterine devices, and we have a contraceptive pill, we have a tubal ligation, and vasectomy. And so we see the numbers on the right column. It said, what is the total number of women surveyed in New Providence? And so I just want to point out something quickly. If you add up everything here on this column, what you get is 129. But I'm going to show you something. This is not a trick question. This is not a trick question. This is 129 births. So add up everything right here, get 129 births. But the question asks you, how many women were surveyed? right here, this is information. They assess 100 women. Even though the number of births is greater than the number of women, it doesn't mean that one woman experienced one birth. So it can be that more than, like for example, some of the women, they can have more than one birth. In other words, they can have more than one children. All right. So not because this is 129, it means that it is the total women. No, it's not a trick question at all. 100 women were assessed, which means 100 women were surveyed. In fact, this is said right here again, per 100 women. So a fact of the matter is that the 100 women were surveyed. So let's put the answer right here. The total number of women surveyed in New Providence was actually 100. All right, not a trick question at all. Again, number of birth is different from the number of mothers. Some mothers can have more than one children. All right, so not a trick. It's not a trick at all. All right, for part B, one is to identify two methods considered to be the least reliable method of contraceptive. All right, so in terms of unreliability, you're looking for those that give the highest number of births. All right, so let's go back into the chart and looking for the births that are the highest. And so looking at birth, here we have highest number here is 38 and also 36. So those is the highest number of children actually born by using these contraceptive methods. So rhythm method, safe days, that definitely cannot be good. Withdrawal of penis before ejaculation, those are the highest number of children born by using those methods. So they are the least effective in controlling pregnancy. So it's going to be rhythm and the withdrawal method. So let's put it right here. So two method. One is, I'll just say, is the rhythm method. So it's the rhythm method as they mentioned there. All right, so the rhythm method, and also the withdrawal method. Okay, so the withdrawal method. Those two methods are the least effective. All right, so for part two, so for each method named in B1, state one reason why it may be considered unreliable. All right, so let's think about the rhythm method. The rhythm method is when you're going to judge when is ovulation going to take place, when is the safe days, and normally just after menstruation, 5 days, up to 5 days after menstruation is normally considered the safe days. Because at those days, it is unlikely for a female to release an egg. And notice I've said unlikely. We're not saying it is impossible, which is a different thing. All right, so unlikely is not the word impossible. So two different things. So here now, just to mention here for method one, why the rhythm method is so unpredictable is that, or not so reliable, I should say, is because ovulation can be early or late. Okay, so it can be early or late. All right, matter of fact, we can say it can fluctuate. All right, and so just to make a note right here, it is not always set. It is not always a set period. It is not always a set period or days. Not always. A matter of fact, ovulation can be affected by the external factors as well. So ovulation, let's make a note right here that ovulation can be affected by many factors. Okay, let's say many factors. And so some of the factors could be stress. Some of the factors could be medication that you're taking. Some of the factors can just be hormonal problems or hormonal issues. All right, so your hormones may not always be regulating as normal. And so you end up ovulating earlier or even later than normal. And so you may misjudge when it is actually safe. All right, and so method two now for the withdrawal process, withdrawing the penis just for ejaculation. Just to make a note that pre-ejaculation, right? All right, pre-ejaculation can actually cause pregnancy. The pre-ejaculation can cause pregnancy. All right, can cause pregnancy, or we can say have sperm cells, pregnancy, or have sperm cells, right? Just to make a note of that. All right, so definitely pre-ejaculation. So if you ejaculate before, like really not true ejaculating, but you may have a slight amount of ejaculation before you withdraw, then it can actually cause pregnancy as well. All right, so pre-ejaculation is a serious thing. All right, all right, so cool. All right, so let's move on to the next question now. Let's go down to the next question. Our next part of the question, it says, state how the pill prevents pregnancy. And when you use a pill, now the very first thing you need to know about pill is that the pill themselves contain some hormones. All right, and remember that the entire menstrual cycle is controlled by hormones. So there are many reasons here that the pill can actually do, or the effects that the pill can have in controlling pregnancy. Looking at the how though. All right, so one is that one answer here is that it prevents ovulation or inhibits ovulation. So it prevents ovulation, or it simply inhibits ovulation. All right. Or matter of fact, let me specify this now, because ovulation is controlled by what I call the LH, which is luteinizing hormone. So it inhibits LH, which is the luteinizing hormone. All right, so that's one, because LH is responsible for ovulation. If you're not producing ovulation, or if the pill prevents LH from producing, then yes, you will not ovulate. All right, our next reason, or our next way how the pills work is simple to break down. So the pills may also break down breaks down the endometrium, which is the wall of the uterus. Break down the endometrium. All right. And the endometrium is a uterine wall. Let me just put uterine wall right here. So break down the endometrium, which is the uterine wall. All right, the uterine wall. So once the pill break down that wall, then yes, definitely. And what these pills contain? They contain progesterone. So these pills that break down the walls, they are high in progesterone, and this is due to progesterone. All right, so progesterone is in these pills. All right. All right. The progesterone. So the pills that actually break down the wall, they contain progesterone, right? All right. So another thing right here that can happen is that they cause the cervix to produce a lot of mucus. So so let me say causes the mucus, or cause the cervix, causes the cervix, all right, the cervix to secrete a lot of mucus. All right, a lot of mucus. And the mucus now will clog the cervix to prevent sperm from going up. So cause the cervix to secrete a lot of mucus, preventing sperms from entering. All right, from entering the uterus. All right, enter the fallopian tube. All right. So let's say entering. All right. So let's prevent sperm from entering let's say entering, because the sperms have to pass the sperms will definitely have to pass the cervix to enter the fallopian tube. They go to the uterus, then up to the fallopian tube, right? All right, so kind of drop down to the next part, but we so best we could write that down. I was trying my best to kind of see if I could ignore that, but anyhow, it's there. All right, yeah, I think I could minimize this. If I minimize this, it's going to fall right back in place. Excellent. All right, so good. All right, so it causes the cervix to secrete a lot of mucus, preventing sperms from entering, and we say entering the cervix, or entering the uterus to reach the fallopian tube, right? So there's no way the sperms will end up reaching the egg in the fallopian tube if it cannot pass the cervix. All right, so sperms cannot pass the cervix, cannot reach the fallopian tube for fertilization. Now for part D, for part D, it's a use the information, right? So here's a use information. In the table, state one mechanical contraceptive method. So one mechanical method is a physical method, and let's go up here and see what are some of the physical methods that are listed here. All right, so the rhythm method, all right, that's just deciding where. That's not necessarily physical, but condoms are mechanical things. So condom is a mechanical thing, is a physical thing. Diaphragm is also mechanical, but spermicide is a chemical, just to mention that. So it's a physical and a chemical. Let me see again. IUDs, they are also physical. All right. All right. So those are two. Tubal ligation and vasectomy, those are surgical method. So we have two answers here: the condom or the IUDs, which is interuterine devices. So for part D right here, we're going to put IUD. So IUD, those are physical stuff or mechanical stuff, or condoms. Condoms are definitely physical things as well. All right, so part E1 now, we said, what is tubal ligation? So tubal ligation is simply the cutting and tying of the fallopian tube. In some cases, they burn it as well, right? Cut, tie, and burn in some cases. So this is pretty much, as a basic way to define it, is the cutting and tying. I say the cutting and tying of the fallopian tube, all right? The fallopian tube. That's what tubal ligation is. You cut the tube, you tie it, and in some cases you burn. So since burning is not always, so you're gonna just say cutting and tying of the fallopian tube, right? That's a basic way to do it. All right, to state one advantage of tubal ligation. One disadvantage, not advantage. Now, a disadvantage is simple because it is irreversible. So it is irreversible. And being irreversible, it also means that if the female eventually want to decide to get pregnant, it may be difficult to do so. All right, so this is irreversible. All right, I think you're right. So irreversible, let me give a next option here. You can also call this permanent, okay? There's also a permanent thing that is irreversible or permanent. All right, so our next thing is a state one disadvantage. I put it on the wrong place right here. Let me put it at the bottom on this line. So I have the wrong line. So this is where it should be, state the disadvantage. It is irreversible. All right, again, or permanent, okay? All right, permanent. All right, let me put this back on a bigger font so you see it a little bit better as well. All right, that should work perfect. All right, so that is the reason for disadvantage there for tubal ligation. Again, simple because if the female decides to say, listen, I want to get pregnant, I want a child now, then it's going to be a little bit difficult, right? All right, so for part F, it's a state, part F, let's go on part F. So part 2 is state one disadvantage. Part F now is apart from being a contraceptive, the condom also effectively serve another function. Give the other function of the condom. And a matter of fact, the condom is the only one that does this, and it is to prevent STDs or STDIs. All right, so it prevents STDs or STDIs. I'm just to make a note right here, right? Condoms, yes, they are useful and they may prevent STDs, but again, they're not 100% effective because if they're not used properly, then the effectiveness of them decrease because again, if air is trapped in the condom, it can burst easier and then it could cause problems. All right, so a matter of fact, pieces of it could also leave inside of the female's vagina, which could cause infection as well. And not only that, if it's burst, then sperm cells could get themselves up into the female and get her pregnant also. And also contraction of STDs. All right, so only if they're used properly without damage, then yes, because there's a right and a wrong way to use condoms. All right, and yeah, and also to make a note too, there are some new condoms that are made that are not latex, that those will allow microbes to pass through, and those can be a little bit also dangerous in terms of contracting STDs. So you have to actually know the type of material. But latex condoms, which is the standard condoms, those are the one that prevents STDs. All right, so let's go to question number 3A. Is to give the SI units of force. And so the SI unit for force is N. All right, so the unit is N. What N means is actually newtons. All right, so it actually newtons. All right, but the symbol, and it's a SI unit, so just write N, and then newtons will be the name of that symbol. For part B, it's a bathroom scale reads 500 Newton when a student stands on it at rest. State the size and direction of the force of the student on the scale So weight is a force, and this is measured in Newton, so it's the same value. So it is still 500 Newton. It's still the force. So the force is 500 newtons, and the weight of a person, which is the force of a person, is acting downwards. So it's acting downwards. I must say acting downwards because it's a direction as well. To act downwards. All right. Right. All right. So what? Act downwards on the scale. Let's say on the scale. All right. Act downwards on the scale. Now for part 2, determine the size and direction of the force of the scale on the student. So remember this law, which is Newton's third law of motion, and it states that to every action there's an equal and opposite reaction, right? Which means that if you act on object A, if object A acts on object B with a certain force, then object B acts on object A with the same force but in opposite direction. So once you apply a force to any object, that object will apply another force opposite to that force, but is the same size of force. So the scale will also act on the student with a 500 Newton, but in this case, it will act upwards. All right, so they're acting oppositely from each other. So in terms of diagram, let me quickly do a diagram for you. Yeah. So if you have a scale here, let's say the scale is here, all right? Don't mind it not drawn so properly. If the student is standing on the scale, the students will act on the scale that way with the 500 Newtons that way. And also the scale going to act up oppositely to the student weight and act upwards with a weight of 500 as well. Because again, to every action, there is an equal and opposite reaction. All right, so the scale acting up upwards on the student with 500, the student's acting downwards with that same value, 500 Newtons as well. All right, now this one now is about a aeroplane. You want to be a pilot, you need to know all of these stuff. It said the diagram below now shows the forces acting on an airplane flying at constant velocity. All right, so it's a name the forces acting on the plane at, and let's see if it give us all of them. So we don't need to label it on the diagram itself. Okay, so A, B, C, and D. All right, I keep it right there. So A is going up, so it's called, that one is called the lift. That's the lift. That's what the name of that force is called, the lift. B is going forward, and that one is called the thrust. Okay, so thrust go forward, and C is going down, so that one is called the gravity or the weight. So we call this one the gravity, or simply the weight of the plane itself, which is mass times gravity, the total mass of the airplane and its content multiplied by gravity. So we call it gravitational force or weight. Now D now is going backwards, and that one is called the drag. That's the drag on the plane. So those are the 4 forces that you may see on an aeroplane. The upwards one, which is the lift, the one going forward is the thrust, the one that going downwards is the weight or gravity, and the one that is going backwards, that one is the drag. All right, let's see now, next part of this question. It said, explain the relationship between B and D when the airplane is moving at a constant velocity and at a constant height. So let me just quickly show you something here. We're talking about B and D, and B and D is the forward and backwards one. The B is going forward, the D is going backwards, right? So D is the drag, B is the thrust. All right, so let's quickly talk about those, yeah? All right, so what's the relationship between the thrust and the drag? If you move at a constant velocity and also the constant height, that means you're not going higher, you're not going lower. And so what must happen here is that both of them, they must be equal. So the relationship here is that they are equal. All right, they are equal in value. All right, in other words, the net force there is going to be 0. They are equal, which means the net force acting forward or backwards is going to be 0. And remember Newton's third law of motion, no, not third, first law of motion, Newton's first law of motion, which states that if an object is moving, it will continue moving at that same speed unless an external force acted on it. So therefore means if the net force is 0, that object will continue to move in that same exact way unless you apply a force that is greater than one of the other forces, and it will cause it to either change direction, speed up, or slow down. All right. So for part D, is to explain the relationship between force A and C, and force A and C has to be up and down, right? Because based on what B and D was, A is going up, C is going downwards. And it said when the airplane is about to land. Now, to avoid damage, because that's what we need to think about, because if a plane just drop out the sky like that, then boom, going to mash up, people will die. So to prevent that from happening now, what must happen first? A number of things happen here. Is that the upward force, which is the lift, that one must reduce. All right, so A reduces. That's the first thing going to happen there. It reduces. Or get lower, decrease. It reduces at a lower value. Let me say at a lower value, value than C, and C is the weight or gravity. Because if A is greater than C, then the plane going to stay up in the air. So if A reduces, the lift is reduced, and so the weight will pull the plane downwards towards the earth, because gravity pulls things towards the earth. All right, so that's the first thing happen. All right, so now what is very important now on landing now? So immediately, all right, so immediately on touching the earth, so immediately on touching the earth or touching the ground, all right, this is something that's very going to happen here now. A must equal to C, because if A is not equal to C, what's going to happen? The weight going to collide on the ground so hard and break the plane up. So what's going to happen now? A will become equal to C to keep the plane just very, well, let's say very micrometer away from the ground, so the wheel don't plunge into the ground and cause the plane to crash. All right, so immediately touching the earth or the ground, then A must equal to C. And this is, let me say ground, let me say earth or ground. All right, and the reason for this is to avoid, let me say to avoid damage. So this is very important, to avoid damage. All right, they must give you that piece of information right there, just in case they may ask that in another exam. So why A must equal to C at immediately on touching the ground is really to avoid damage. Because if you allow the weight, remember now, weight causes things to fall down to the earth, or gravity pull things towards the earth. So if planes keep on pulling towards the earth and there's nothing to stabilize that force to make it balance at a point, then you're going to plunge into the ground, and then the plane will actually break up. And of course, it can cause death as well. All right, it could cause serious injuries and serious mechanical problems and physical damage to the airplane. You know what? Let me just go back to this question a little bit. Bear with me a little bit. I want to give you some information here about all the forces or the relationship that you may want to know. All right, remember that A and C are the one that acting up. A going up, which is the lift, and C coming down, which is the weight. So let me just quickly give you some quick information here. So firstly, when A is equal to C, what happened here is that you have a steady height. Okay, so you have a steady height. I just want to make sure you understand these. So you can write these down. Go look back at the diagram, and you will kind of have all these relationships. The next relationship is that if A is greater than C, what we're going to have here is that you have an increase in height, because A is going up, right? So if the lift is greater than the weight, then we're going to increase in height. All right, and another relationship here, if A is less than C, then what's going to happen here, the plane will eventually fall. All right, that actually is landing, falling. It will fall or start to land, right? All right, so let's look at the relationship between now B and D. So B is going forward, which is the thrust, and D is going backwards, which is the drag. And so when B is equal to D, and they asked us this in the question already, then what we have here is a steady speed or constant velocity, right? So steady speed. And what if now we have B is greater than D, which means the thrust is greater than the drag? Then what you're going to have here is that the plane will accelerate, or you may say it will the plane will accelerate or increase in speed, right? So you have an increase in speed. All right, so that's what will happen there if A is greater than D. Now, what if B is less than D? Then what you have here now is that as a situation of deceleration, it will deceleration. And if you don't want to write the word deceleration, what you can have is that they will actually slow down. So deceleration or slows down. All right. Right. So those are the relationship between all the forces there. All right. So those are the 6 possible relationship between all the forces that they mention on the aeroplane. All right. Next question here. Question number 4 now. It says many everyday substances are made up of alloy. An example of an alloy is steel. And notice at the bottom is the particle diagrams of iron and steel are shown. But in the first diagram, you have iron only, and then in the second diagram, you have a non-metal X. But here now they ask us to define the term alloy. All right, and so the term alloy now is alloy is really a solution, or a mixture. So it is a mixture or solution. So let's write here. It is a mixture, all right, or solution. Mixture or solution. All right, let me take my time there. Or solution. Come on. All right, or solution of two or more metals, right? Of two or more metals. All right, here we go. All right, so that's what an alloy is. Now for part B, it said name the nonmetal X in a diagram which is used to make steel. So the nonmetal that is used to make steel here, it is actually carbon, all right? So carbon is placed within steel, and then we'll give you the reason right here. And it's a state effect of the addition of nonmetal X on the melting point of steel. And so what that carbon will do to steel is to actually increase its melting point. So the melting point will increase, all right? So you can make a note that the melting point will increase. Well, for part C, is that iron is malleable because the layer of atoms can slide over each other when a force is applied. Use a diagram to suggest the reason why steel is less malleable and stronger than iron. And so if we go back to the diagram, what you'll notice here is that if you notice I put the nonmetal in, so therefore all the particles will not be able to slide over each other, just like in the first diagram with iron alone. So iron alone will allow all the particles in whatever direction to slide over each other really easily. But for this one, they may be able to slide here, they may be able to slide here, but they're going to have a difficult time to slide through the middle. All right, so it's going to be difficult to slide across each other in that middle portion right there. Right, it's going to be a little difficulty. So let's talk about why now the malleability will decrease. Just to make a note right here, right? When I say metal is malleable, it means that it can easily bend. All right, that's how metals bend. They can bend it or hammer it into a different shape. All right, so it can be bent in different shape or hammered into different shape. So here now, first to make a note right here is that the non-metal, which is carbon. So the non-metal, which you know that is carbon in this case, the non-metal create what they call a resistance. They create a resistance, or a resistance force. They create a resistance, let's call it a force, a resistance force, reducing the movement. All right, so reducing the movement of particles, right? Or so movement of particles, or ions, so movement of particles. And let's put ions in the bracket. Yeah, let's put iron in the bracket. That would make sense. So particles we're talking about here is iron over each other. Okay, particles over each other. That's what carbon does. So that's why it's not so malleable. It's like easy, very difficult to bend compared to when it's just iron alone. All right. And a point to note as well is that the non-metal is more even brittle. So the non-metal is a brittle thing. It's not malleable, it is brittle. So the non-metal is more brittle than iron. Okay, just to make a note as that as well. So it's easier to break rather than to bend. All right, so brittle means it's easier to break than to bend. All right, so it's easier to break carbon rather than to bend it. All right, so part D is a give another advantage other than strength for making objects from steel instead of iron. So to make the advantage of using steel rather than just pure iron is that yes, it's harder. Instead of being malleable, it's harder. It also decrease. Let me just make a note, right? It decrease because non-metals do not conduct electricity nor heat. Then it decreases thermal. So let's say it decreases thermal and electrical conductivity. All right, so those are two things that happen there. All right. Also, a point to note as well, another option that you can make right here, again, it is more resistant to corrosion. All right, let me say, and more resistant to corrosion. All right, so that's another one that we can actually mention. All right, and also too, it is less reactive to acids. So, and what corrosion actually means, because corrosion is when it's easy to break down by acid. So non-metals do not react with acid so easily. All right, so it is less corrosive than just using pure iron. Iron reacts easily with acid, so acid can corrode ions really, really easily. All right, so now for part C now, for part E actually, is to complete the following table by filling in the blank. And it said solder, and it said main element making up the alloy. So there are two main elements making up solder, and solder is made up pretty much of tin and lead. Okay, so tin and lead are the two main components. Yes, there are other components there, but the main component will be tin and lead. Now, copper and zinc, the alloy for this is actually called brass. Okay, so copper and zinc make up brass. All right, next part of this question now is to give a use of solder, and solder can be used for many different purposes. So generally, we use to join them. We use to join metals together. So you join up metals, especially for those persons who are in electronics. We definitely know we can use it in electrical components, right? Or let me say, or to join or repair. Let's say join or repair electronic components. Okay, electronic components. All right, so that's what solder is used for. All right, let me just give one little thing that I think you need to know right here. We talk about solder, we talk about brass, but there is another alloy that is common as well that I think you need to know, and it's actually called bronze. All right, so we can know about bronze, and bronze is really a mixture of copper and tin. Yeah, so copper and tin will make up bronze. All right, so just make a note of that. So copper and zinc is brass, copper and tin is bronze. All right. All right. So let's jump on to our another question right here. Question number 5. We're sliding through this quite easily. All right. So we should finish in good time. Is a state what is meant by the terms fruit and seed. All right. And so a fruit is really a developed ovary. All right. So when they talk about a fruit, what a fruit is, it is a developed ovary containing, very important here, containing seeds. So seeds must be present in fruits. A fruit must contain seeds. All right. All right. And so seeds now are fertilized. They are a seed is a fertilized. It's a fertilized fertilized ovule. Okay, the fertilized ovule capable of germinating. So it's capable of germinating, capable of germinating. All right, and so a seed can able to germinate into a new plant, right? Okay, so that's a fruit, that's a seed. Fruits come from ovary, seeds come from ovules, all right? Now, part B now is fruits and seeds can be carried many distances away from their parent plant by various methods. Now, explain fully 2 advantages of seed dispersal. So let's talk about the first one here. And there are many advantages we can actually talk about, but just look at the main ones really. And so the main reason why fruits would want to disperse from the parent plant is really to reduce competition, right? So here's to reduce competition. All right, so that's one of the main reasons right there. Because if too much plants are at the same spot, they're going to compete for the same resources, right? And that's to make a note here that when plants are spread out, they do not compete for the same, let's say for the same resources, And some of the resources that we're talking about here, let's say example resources, we're talking about water from the soil, we're talking about water, we're talking about nutrients, we even talk about carbon dioxide. All right, so too much plants in one place, they have to compete for these nutrients. And even light, let's put light there too, because the bigger trees will get the light, but the shorter trees that honor the bigger trees, they will not get enough light as the taller trees. All right, so those are some of the resources have to compete for. Another one here is to increase biodiversity. Okay, so another one you can say here is to increase biodiversity. And biodiversity is really a big thing when you're talking about sciences today. So increase biodiversity. And really how this work is that the increase in biodiversity really will provide a lot of different food or create a larger ecosystem or larger food chain or food web. So whilst food spread out, trees spread out. So let me just make a note here. When trees are spread out, all right, they create more food or provide. I say let's say provide. Let's say all right, let's create more habitat. All right, habitat and supply more food. All right, and supply more food for organisms. Okay, for organisms. All right. And so that's very important. And so once you supply more habitat and food for organism, this now will increase biodiversity. Okay? So increase biodiversity. All right. So great. So that's how we do it. And again, there are others, as I mentioned, that you can also think about increased survival of a plant as well. So I'm going to just put a note right here. So just to mention them. So here we could have increased survival. So the plant species itself could also increase in survival. All right, so increase survival of the species. Okay, so increase survival of the species. That's one. And another one that you can also mention here is also to reduce diseases, because like any organism, once you're clustered and once one organism contract a disease, then it's easy to spread amongst the others as well. So definitely, the possibility to reduce the possibility of diseases. All right. Once the population is increasing, once you have an increased population in any organism, there's a high chance for more disease, right? So population should be low, spread out as much as possible, so you don't transmit disease from one organism to another. That's how it should work. And so anyway, see clusters of animals or plants, then diseases can be transferred quite easily. All right, the part C is in the table below, identify two methods of seed dispersal and name the seed dispersed using that method. So method of seed dispersal, so there are many again. Let me just talk about some common ones first. So we have some by wind. Let's give you all three of them. We have water, can also disperse seed as well. Animals can also disperse seeds. And one other here, it can be explosions. Some fruits explode and also cause seeds to disperse. So let's talk about wind. An example of a plant that is dispersed or seed that dispersed by wind here is the dandelion. All right, dandelion is a pretty much simple example that most of you might see generally in your yard as well. Dandelion definitely cause seed to disperse. A next one that is also common here again in Bahamas is the yellow elder. So the yellow elder is another plant as well that may disperse by the by wind. Now for water, let's think about water now. Do you know any plant? Think about it. Any plant that can be dispersed by water. All right. And well, only one example I'm thinking about right now is actually coconut. So coconut is one example I'm thinking about. Okay, dandelion. That is a supposed to be right there. Dandelion. All right. So animals now. Dispersal by animals. Could be like the guava. Like especially when cows or goat may eat the guava. What will happen here is that they will carry the seeds or they pour the seeds, and then the guava will grow in a different place. All right. So sometimes you see guava trees because of cows or donkey or whatever, any animal that eat the guava, even lizard, for example, they pour out the seeds because the seed is so hard and small. They pull it out. They do not digest the seed. The seed cannot be broken down in their system, and so they pull it out in their feces and then eventually grow in that spot. Yeah, so that's a cool thing anyhow. So you have nutrients. The seed have nutrients to grow the feces from the animal, and eventually grow into a nice new nutritious plant, right? Yeah, an explosion now. Explosion, a typical one I'm thinking about is the poppy plant right here. So the poppy plant is one that explode by well, separated seeds or spread the seeds out by explosion, right? You have a round fruit. When it explodes, the seeds eventually fly all over the place. All right, number 6, and we very close to finish. So number 6 now is to define the following terms: wavelength and frequency. Now, wavelength now is the distance between two equal consecutive points on a wave. So I want to say the distance. So the distance between two consecutive, or let's say two equal, or the points must be equal, two equals consecutive, all right, consecutive points on a wave, all right, on a wave. So that's what a wavelength is, all right. All right, so let's correct this word here, all right. All right. All right, so here now, what is frequency? So frequency now, just to mention a note, something you need to know about frequency is that frequency is actually, frequency is, let me say, the inverse of period, just to make a note of that. All right, so frequency is the inverse of period. All right, so inverse of period, which means that it's 1 over t or 1 over f to be reversed. I'm going to show you what I'm actually talking about. So it's a reverse of it. Let me just correct this word quickly first before I go into that. Yeah, so before I go to that. So let me show you on this side here that 1 over f, let me show you what I mean by reverse of each other. 1 over f, which is, let's say, call that 1 over f is frequency, is equal to period, which is t. And so for any waves, you need to know this. And so t is equal to 1 over f now, let's say f frequency equals to 1 over t. So they are reverse of each other, okay? So period and time, period and frequency, they are the reverse of each other, just to make a note right there. But in terms of definition though, we can't define it as that. That is the reverse of time, reverse of period, but it is the number. So it represents as the number of waves, produced per second, okay? Number of waves produced per second. All right, so it's relative to time. So the amount of waves or points passed in a given time, which is in seconds. So that's why you need to know that the relationship between period and time, period and frequency, they are inverse of each other. Okay. All right, just to mention a note, mention that note. That's very important for you to know. So again, the wavelength is the distance between two consecutive points on a wave. And these, and a matter of fact, a way to define this as well, you can say it is a distance between two consecutive crests. Let me put that in here. I could make a note here as well. For that one, it's the distance. Let me just put this piece here. So some of you will know it, remember it as this. So the distance between two consecutive, all right, so two consecutive crests. All right, so that's very important to know as well, right? So they can do it like that. Or you can say trough. Let's say even trough too, because it's the same thing. Two consecutive crests or troughs. All right, that's very important. Yeah. So that's a wavelength and that's a frequency. All right, so you need to know to calculate frequency from period and period from frequency. Now, note for this part and part B, the diagram below shows the displacement time graph for a transverse wave. And a transverse wave, we notice a transverse wave because, again, the vibration or the particles of the wave they are perpendicular to the direction of the wave. So direction is the middle point right here, showing the arrow going forward. All right, and so it's on the diagram labeled the amplitude. All right, so we're going to label the amplitude. So what we're going to do is draw a line here. And so the amplitude is either here, which is the height from the rest position. Okay, there's something going wrong here. All right, let me just erase this. All right, let's take out everything. All right, I will draw it. All right, so the amplitude is from the highest point to the undisturbed position. Now my line is all bent up. All right, that's not looking too nice at all. I wasn't have a nice line before. All right, let's get a nice line in. All right, let's keep my hand very straight and not so. Okay, that's the best. All right, let's start wasting time on that. All right, so there is an amplitude there. All right. Or you can also label this point as well as an amplitude. It's the same exact thing, all right? So from the undisturbed position to the highest or lowest point on the wave is called an amplitude. So you can just call this A. All right, so that's amplitude. You can label it as amplitude. I'm just going as fast as I possibly can. Just call it A. Again, I was talking about wavelength. Just to make a note right here. From here, with this one crest, to this other crest, that's the wavelength. And the wavelength is symbolized by a symbol called lambda. So it is a symbol looking something like that. It's a lambda, right? And also from the trough to the next trough, yeah, that's a wavelength as well. So once it's two equal consecutive points, it's also a wavelength. Just to be a little bit technical, from this point to this point is also a wavelength. All right, just to be a little bit technical here. I want to show you that equal points is a wavelength. So here is also a wavelength. Once the points are equal and consecutive, they are wavelength. All right, so as I use information on the graph, we need to do something. Let's go up a little bit. It's a state the number of waves show in the diagram. So number of waves, looking for number of wave. Now we look at number of wave is based upon a total cycle. So we're looking at cycle. So from a crest to a trough is a cycle, right? From a crest to a trough is a cycle. So starting from this crest, the whole of this crest to the whole of this trough. So in other words, from point 0 right here to point 0 after the trough. So the point 0 before the crest to the 0 point after the trough is a cycle. So that's one wave in itself. And starting here again to this one, so therefore we have two cycles, which means we have two waves. All right. So there are two waves right here. Let's put 2 here. There are two waves. All right. So you can put the word or you put the number. Really don't matter. There are two waves that are formed. All right. So let's next part of the question here now. It said calculate the frequency of the wave. All right. So we need to know the frequency is the amount of waves produced per second. We're going to talk about that. So let's go up first and see the number of waves produced, which you know is 2, because we just talk about that. But the entire time it takes for 2 waves to be generated is 0.8 seconds. So what we're going to do is put the two waves for 0.8 seconds. So we're going to go like this now. We're going to say 2 divided by 0.8. Okay, divide by 0.8. And so what we're going to get here now, 0.8, 2 divided by 0.8 give it 2.5. So we're going to get 2.5 hertz, and frequency is measured in hertz, by the way. And what this is telling that you have 2.5 waves produced per every second. So for every second, you have 2.5 waves that will be generated. All right. So therefore, it means that based on what you have on the diagram there, you need half of a cycle to get a 1 second, right? That's what actually means. All right. So for every second, you get 2.5 waves. All right. Here's a calculate the speed of the wave if its wavelength is 1.5. So I want to show you something now what speed is equal to. Speed is equal to the frequency. All right, I think I'm pressing down on something too hard here. Let me just take off all of that. All right, let me give it this back again. So speed, again, V is equal to the frequency. All right, so that's the frequency times the wavelength. All right, so the wavelength would be the lambda sign, as I said. So how we're going to work this out now is the frequency, which we work out up there, which is, let me go back a little bit more, you're going to see the frequency right there, is 2.5. So the speed now is equal to 2.5 multiplied by the wavelength, which is 1.5 given here. And so this gives us here 3.75. So it's a 3.75, and this is going to be in centimeters per second, because why centimeters per second is because here on this wave, the wavelength was given in centimeters. So notice here, this displacement here is in centimeters. So just keep everything in centimeters there. Matter of fact, the wavelength is given as in centimeters here as well. So notice even the diagram is centimeters here. So it's centimeters per second. All right, good. All right, so we finished with that part. Let's see if there's that's the whole question there. All right, next question is question number 7. And there's one more after this and we're done. And it said, some materials are poor conductors of heat and can be used as insulator. A student has 2 ice cubes, both made from pure water. The student places one ice cube into a plastic cup and the other into a styrofoam cup. The time taken for each ice cube to be completely turned into water was recorded. The following results were obtained. And so the plastic here took 10 minutes. This is in minutes. The time taken in for the ice to melt here is in 10 minutes. So 10 minutes, and the styrofoam took 25 minutes for it to melt. So here now is to suggest one factor that should be kept constant or keep the same in both experiments. So what you want to ensure that is the same whenever you're doing this is one, you want to make sure the size of the ice cube is the same. So one, you're going to say the size of ice cube. So there are a number of things you could do here, but an obvious one is the size of ice cube. So let's say size of the ice cube, all right? So that's one there. Another one you can also think about is the same environmental conditions. So, for example, temperature. Okay, so there's one factor that should be kept constant. We could keep the same temperature, which means the external temperature. So in the same location, so we're going to make sure that in the same location, so same location, and once in the same location, that means the external temperatures and pressure must be the same. All right, so let's talk about the external pressure. External temperature, all right, temperature must be the same. All right, so that's very important. So keep in the same location to maintain the same temperature. Because if you keep one in a hot room and one in a cooler room, then obviously the one in the hotter room going to melt faster, right? So you want to keep them in the same environment. All right, to make it fair. Now for part B, it says state which cup was made from the better insulator. Give a reason for your answer. And of course, styrofoam is a better one because it takes a longer time to melt, yeah? So notice here, from ice to water, it takes 25 minutes. The plastic only take 10 minutes. So therefore, the styrofoam is the best insulator. It takes a longer time for the ice to melt. So let's say, put it right here, or styrofoam is the best. All right, so styrofoam is the material right here. And this is going to make a note here that the ice, let's say the ice in this container, took a longer time to melt. All right, yeah. All right, so therefore heat wasn't passing through it that easily, right? So it did not allow heat to, too much heat to pass through at all, or allow the ice to absorb too much heat from the environment. Now for part C, so describe what would happen if a rubber stopper is fitted over the two cups. So you put a rubber stopper over the two cups, and therefore mean that you have less contact with the ice with the external environment in terms of air passing into the ice. So what's going to happen is the time for melting would increase. All right. So the time, or it would take a longer time to increase, the longer time to melt. So the time for melting, would increase. Or you can just simply say they will take a longer time to melt. All right, they will take a longer time to melt. All right, so we're good at that. Let's go down to the next part of question now. And here it said, what would be the temperature reading when the ice cube turned into water? Give your answer in degrees Fahrenheit. And just to make a note that as ice melt, the water that is formed is the same temperature as the ice, which is 0 degrees Celsius or 32 degrees Fahrenheit. All right, so just to make a note right there, so it's 32 degrees Fahrenheit or 0 degrees Celsius. So if you should ask in degrees Celsius, you're going to say 0. Because just to make a note, when ice just melt, the water that comes from the ice is the same exact temperature as the ice, just as melting takes place. All right, so that's that for that. Part 2 is which molecule have the greatest kinetic energy? Molecule in ice or molecule in water? And what kinetic energy means that energy in motion? That means which one moves the particle, which of the substance the particles move faster, and naturally going to move faster in water. So water is definitely the answer right there. They have a higher kinetic energy because they move faster. Ice, the particles aren't moving very fast. They actually vibrate about a fixed position. That's solid. So liquid have higher kinetic energy than solid, and gases have higher kinetic energy than liquid. All right, so next part of this question is using the kinetic theory, explain how ice cube change into water. All right, so how it change into water. And let's quickly say this. All right, so firstly is that when heat is added, so let's put that piece here. All right, so let's say when heat is added, all right, when it is added, which means an increase in temperature. So let's say increase in temperature. All right, so when there's an increase in temperature, all right, increase in temperature, the particles here now, the particles gain kinetic energy. What's gain kinetic energy. All right, gain kinetic energy and move faster. All right, and move faster. All right, move faster. Breaking. Let me say, yeah, I can break these bonds. Breaking the bonds. Breaking the bonds. Breaking the bonds that held them together. Yep. That held them together. Yep. That would be it. Yeah. So right there is that when heat is added, there's an increase in temperature, and so the particles gain kinetic energy and move faster, breaking the bonds that held them together. Now, part E of this question now is said in the experiment, the mass of ice cube was 10 grams. The density of ice at 0 degrees Celsius is 0.92 grams per centimeters cube, and the density of water is 1 gram per centimeters cube. Calculate the volume of ice and the volume of water. Now, what I want to tell you before we actually do this is that ice will have a greater volume. Why ice have a greater volume is that when water, and this is unique to water, when water freezes, it expands, which means it takes up more space, which means the particles move further away, and that means the density is less. That's why the density of ice is lower than water itself. And the reason for that, as I say, because the particles will expand, and that's the only liquid actually does that. And if you notice, if you put a plastic bottle, for example, fill it with water, put it in the freezer, the bottle will swell right up. Why? Because the particles are moving away from each other, creating airspace in between, and take up more space, so the volume must be higher. So when you're doing this calculation, if the volume of ice is greater, then that means you're correct. If the volume of ice is smaller than that of water, then you're going to be, you know that something is wrong and you check over. But just to make a quick note right here, that density, let's say density. Density is actually equal to the mass over volume, right? So that's an easy calculation we're going to find right there. So mass divided by volume is density. So we have our density right here. We have our mass, so we need to find our volume. And so volume would equal to the mass divided by density. So for the ice, we're going to have the same mass because mass doesn't change. So 10 grams divided by the density of ice, which is 0.92. So this is going to be divided by 0.92. And this, let's say 0.92. And this will equal to 10.87 centimeters cube. Now for the volume of water, the volume of water again is the same mass divided by density. It's going to be mass because the mass is not changing. The mass is the same thing. Mass doesn't change. So it'll be 10 grams here divided by the density of water, which is only 1. So therefore, that's going to equal to 10 centimeters cube. All right, so notice here the density, the volume of ice is a little bit more than the volume of water itself. All right, again, because ice expand and take up more space. And more space means more volume, right? All right, last question. It said that an experiment was set up as shown below to demonstrate that living organisms produce carbon dioxide. The experiment was left undisturbed for 1 hour, after which observations were made. So here we have boiling tube A with the same as a test tube, boiling tube B, boiling tube C, and now we have net bags here. We have cockroaches inside here, so cockroaches. We have sodium hydrogen carbonate in the bottom right here. And then we have stones and we have germinating seeds. We have sodium hydrogen carbonate right here. All right. And so, all right, just to make note right there. Now we said the boiling tube were thoroughly disinfected before the start of the experiment, just to make sure that there's no contamination. It's a sodium hydrogen carbonate solution is colored reddish brown. So this is reddish brown. It turns yellow in the presence of carbon dioxide. So this is a very useful information now. So if carbon dioxide is present, it should move from reddish brown into yellow once carbon dioxide is present. So listen now. It said describe the expected observation in boiling tube A and give an explanation for your response. So in boiling tube A, we have cockroaches. Cockroaches are a living thing. Yes, they're going to respire. Yes, they're going to produce carbon dioxide, right? So they're going to respire and produce carbon dioxide. So therefore, this should turn from reddish brown into yellow. All right, so our expected result right here, we are expected to see it change from reddish brown to yellow. All right, so it turns yellow. So say change, let's say change from we say reddish reddish brown. So we say this is reddish brown, we said, right? Yep, that's reddish brown to change to. So change from reddish brown, and it will go into yellow as we state. Okay, so reddish brown into yellow. All right, let's put another D right there. Reddish brown to yellow. All right, to yellow. All right, good. And now the explanation now is simple because the cockroach will respire. All right, so let's say the cockroaches, they will respire. All right, I don't like cockroaches at all, you know. They're so nasty. Cockroaches will respire and produce. Here, we're going to produce uh, and produce carbon dioxide. All right. So we expect them to reproduce and produce carbon dioxide unless they are dead. Right. So once they're alive, they will respire, produce carbon dioxide, just like any other animals. All right, so for part 2 now, so describe the expected observation in boiling tube B and give the explanation for your response. And let's go up to the boiling tube B. Boiling tube B is stones. Stones do not respire. Stones do not produce carbon dioxide unless it is limestone. And if limestone have to react with acid, that's the only way you get carbon dioxide from it. But it's a stone by itself. Nothing is happening there. So therefore, we're going to have no change. I'm going to still see reddish brown. So here we're going to see no change. In other words, what we're going to see remaining in the thing is still our reddish brown color, right? Nothing changed. All right? Nothing will change there. Now, the reason for this is because the stone do not respire, okay? All right, so we're going to say it's simple that no respiration took place, all right? No respiration took place. In other words, non-living things don't respire, okay? And again, I'm saying that if it's limestone, though, and it's reacted with an acid, then it's going to produce carbon dioxide, which is a different story because carbonates react with acid to produce carbon dioxide, salt, and water. But there's only the stone there. So no respiration took place, or you can make a note that non-living things do not respire. Okay? So non-living things do not respire. Okay? All right, so that way, or you could actually state it, right? All right, so that will be answer there. Let's see what is next. All right, here it said explain why germinating seeds were used in the experiment instead of green leaves. All right, and so that one now is like a sweet question. Why they use the germinating seeds rather than green leaves? So that's for you to think a little bit. Green leaves, what happens in green leaves is that they will photosynthesize, they will use up the carbon dioxide and produce oxygen instead. But the seeds now, seeds, just a point to note, seeds do not photosynthesize. Remember that. Seeds have their own food. So they absorb the food from the seed and they respire. And instead, they produce carbon dioxide. All right, so seeds do not photosynthesize at all. So just to make a note right here that the germinating seeds respire. All right, respire, producing carbon dioxide, right? Producing carbon dioxide. All right, just to mention that. While the green leaf would photosynthesize. All right, so they photosynthesize. All right, so they photosynthesize. All right. And when they photosynthesize, they producing oxygen, right? So oxygen will be produced right here, producing oxygen instead of carbon dioxide, producing oxygen. All right, so that's what happened there. All right, so it's a name here. It's a name the process by which living organisms produce carbon dioxide. And this process is respiration. All right, this is respiration. Living things respire and produce carbon dioxide by respiration. All right, photosynthesis produces oxygen. It's a state why this process is important in living organism, and it's simple to provide the living organism with energy. All right, to provide energy. Okay, so to provide energy. All right, next part is to give a word equation for the process named in B1. So what's the process for respiration? And in words, it's a word. You also need to know the chemical balance equation as well. So let's start right over here. let's say glucose, but we need glucose to respire. So glucose reacts with oxygen. I'm going to put oxygen here. All right, and oxygen now, they will react together to produce carbon dioxide. So we're going to get carbon dioxide. And also what we're going to get as a result as well is water and also some energy. And the energy that we're going to get here is ATP. ATP. Yep. And so we're end of this review, and I'm so saying, wishing you luck on the examination. Again, I will see you soon. Take care for now.